Hello, my name is Glendani, a member from Group 12, Section 2. For this assignment, I will be in charge to present our minute meeting. For your information, we had a total of 4 meetings. Our first meeting was held on 26 November from 8 to 9 p.m. We used Google Meet as our platform of meeting. The objective of the meeting was to understand the question of assignment and divide tasks equally among us all. The topics discussed were as listed. First, we had to introduce the assignment question, briefing about the convolution and linear time invariant. Second, we discussed and started to divide tasks for each member. And lastly, before the meeting ended, we had set a deadline for the divided task. Our second meeting was held on 28 November from 8 to 9 p.m. with Google Meet as our platform of meeting. The objective of the meeting was to discuss Task 1 and Task 2 together among our members. The topics discussed were as listed. First, we discussed the coding of our task. Each member presented their solutions before discussing the problems faced by each other. After corrections were done, we updated the corrected version into our WhatsApp group. Then, we set a deadline for the correction to be done. Lastly, we decided on the date and time for our next meeting. Our third meeting was held on 10th of December from 8 to 9 p.m. with Google Meet as our platform of meeting. The objective of the meeting was to discuss contents of our report and distribute the task equally. The topics discussed were as listed. First, we had reviewed and discussed the coding and manual calculation of each task. Second, we divided the report duties into 7 parts. A Google Doc was then created and shared in the WhatsApp group. Shasha is assigned to compile all information and results, while Arif will edit the video. Then, we set a deadline for the report to be done. Lastly, we decided on the date and time for our next meeting. Finally, our final meeting was held on 30th December from 8 to 9 p.m. with Google Meet as our platform of meeting. The objective of the meeting was to perform a final check-up on our report. We had performed some check-ups and discussed progress in our report.
Each of us has our own roles. Starting with Arif, he is in charge of doing solution for task 2, analysis and conclusion. Next is Shasha. She is in charge to do the objective, manual calculation for task 1, and preparing slide for our presentation. Shahrul is in charge for methodology and is also in charge of doing task 2 alongside Arif. Lastly, Gwen is in charge of minute meetings and develop MATLAB program for task 1.
Objective. The purpose of this assignment is to calculate the convolution operation to describe the response of an LTI system and the use of MATLAB to plot the result of this operation. In the assignments, students will analytically evaluate and verify the result using MATLAB.
A linear time invariance, which is known as LTI system, is a concept in signal processing and system theory that describes a particular class of system, which is there are two, which is linear and time invariance. The system is considered as a linear if it satisfies the principle of the superpositions and homogeneities. Superpositions mean that the response to a sum of multiple inputs is the same as the sum of the response to each individual inputs. Homogeneity means that scaling the input signal results is in a proportional scaling of the output signal. Then the system is time invariance if its behaviors or response does not change with respect to time. In other words, the system characteristics and response remains constant over time. The convolutions operations plays a crucial role in understanding and analyzing the behaviors of LTI system. Convolution is a mathematical operations that combine two functions to produce a third, especially how one function modifies the others. Understood the notions of convolutions, whether in continuous time via convolution integral or discrete times as convolution sums, and how it relates input, impulse, response, and outputs. To simulate and visualize system behaviors, we can use software like MATLAB, Python, and others. So that's it for the methodologies.
Okay, so here is our solution for task 1. We have compiled the codings for question 1 until 3 into the same script. So for line 4 until 7 is the functions of the signals based on figure 2a and figure 2b, and also question 2 and question 3. For line 10 is the convolution integral. Line 13 is to define the convolution result as a function of t. Line 16 until 22 is the plot signal for GT. While for line 25 until 31 is the plot signal for HT. Line 34 until 40 is to plot the signal of ZT. And lastly, from line 43 until 48 is the plot convolution result Y convolve. Okay, so these are the results from the coding earlier. We have obtained exactly the same signal for figure 2a and 2b. Meanwhile, signal for additional operation ZT and convolution operation YT look like that. This will then be proved by manual calculation that will be presented by Sasha.
Task 1, question number 2, manual calculation for ZT equals to GT plus HT. The question is the addition for GT plus HT. When t equals to -1, GT is equal to 0, meanwhile HT and ZT will change from 0 to 2. When t equals to 0, GT is equal to 1, HT will change 2 to 0, and then ZT will change 3 to 1. When t equals to 1, GT will change from 2 to 0, HT will change 0 to 1, and then ZT will change from 2 to 1. When t equals to 2, GT is equal to 0, HT and ZT will change from 1 to 0. Task 1, question number 3, manual calculation for convolution of YT equals to GT times HT. Convolution is the interaction between input signal and impulse response. The output of any input signal can be obtained from the integration between input signals and the system impulse response. For case 1, when t less than -2, there will be no overlapping. That is why we get YT equals to 0. For case 2, in range between -1 and -2, they are overlapping, so we need to integrate with limit t plus 1 to -1. After that, we integrate, we will get YT equals to t power of 2 plus 4 t plus 4. For case 3, in range between 0 and -1 also have overlapping, so we need to integrate with limit 0 to -1. Then we will get YT equals to 2t plus 3. For case 4, in range between 1 to 0, there are two overlapping areas. So we need to integrate both with limit 0 and t minus 1, and the other one with limit t plus 1 and 1. After integrate, we will get YT equals to -1 over 2 t power of 2 -2t plus 3. Case 5, in range 2 to 1, they are overlapping, so we need to integrate with limit 2 and 1. After we integrate, we will get YT equals to t minus 1 over 2. For case number 6, in range between 3 to 2, we have overlap, so we need to integrate with limit 2 and t minus 1. After that, we will get YT equals to -1 over 2 t power of 2 plus t plus 3 over 2. So finally, we will get values where shows that t range and the value of YT.
I want to present about task 2. The question is a signal FT is fed into an LTI system HT as shown in figure 1. Analyze output signal of the system YT, and our FT is shown as in the picture. And next we make the graphical signal for HT that is include with amplitude scaling and also time scaling. And then we put the signal FT and HT on the same axis. For the case 1, t less than 0, so YT equal to 0 because there is no overlapping on the graph. For the case 2, 0 less than t less than 0.25. So the equation is YT equal to FT multiplied by HT, convolution with HT. The lower boundary is 0 and the upper boundary is t. This is because in the overlapping or shaded region, starting with 0 and ending with t. So we integrate it and we get the final answer is 1.5t. For case 3, 0.25 less than t less than 0.5. The equation is YT equal to FT top convolution with HT. The boundary is 0 to 0.25. And then the amplitude is 1, amplitude for FT is 1, and the amplitude for HT is 1.5. And then we integrate and multiply and integrate, and then we get 375. For the case 4 is 0.5 less than t less than 0.75. The equation is yt equal to f tau convolution with ht. The lower boundary is 0 to 0.25. The amplitude ft is 1 and the amplitude for ht is 1.5. And then we multiply and integrate like just now. We get 0.375 again.
The case 5 is t is between 0.75 and 1. As we can see in the figures, the shaded region is between the t minus 1.5 to 0 to 0.25. So as we see that, we integrate the values of the amplitudes, which is 1 and 1.5, by multiplying it to get the 1.5. Hence, we integrate the values and use the limits to get the yt's, which is 2.625 minus 1.5t. And for the case 6, as we can see, for the t between 1 and 1.25, there is no overlappings. So there is no shaded regions, which means yt is equal to zeros. And for the case 7s, which is t is between 1.35 and 1.5, we can see that in the figures that there is a shaded regions between 0 to 0.25. And as we can see, the amplitude is 0, -1 and 1s. By multiplying the amplitudes, we can integrate the values and put the limits and to get the values, which is -0.25. For case 8, which is 1.5 is less than t and less than 1.75, we can see the shaded region is around 0 and 0.25, which is same as the before, which is -0.25 is the value of the yt's if we integrate the values. And for the case 9, which is t is between 1.75 and 2, we can see the limit is t minus 2.5 to the 0.25 with the amplitude at 1 and -1s. So by integrating the values and put the limits after integrates, we can see the values of the yt is 2.25 minus t. And for the last case, which is case 10, which is t is bigger than 2, we can see there's no overlappings. So there is no shaded region, so which means yt is equal to zeros. In conclusions, the output signal will be drawn based on all the values of yt that we have obtained. In the figures, yt's, the graph has been plotted based on the values of yt that we obtained. So that's it for the solutions of task 2. Thank you.
In signal and system theory, the analysis of linear time invariant LTI system and convolution is fundamental to understanding the behavior of dynamic system. LTI system offer consistent response to input signal throughout time due to their linearity and time invariance. The research entails a thorough examination of the convolution operation, which is a mathematical procedure that blends input signal and system reaction to generate output. In signal and system theory, the study of LTI system and convolution is critical to understanding the dynamic behavior of system in response to input signals. Linearity and temporal invariance principle provide a solid foundation for consistent and predictable system response throughout time. Convolution is a useful mathematical technique for modeling the intricate interaction between signal and system, whether used in continuous time or discrete time context.